Hello, welcome. We are going to be doing section 4.6 today, which is page 149. So we've already discussed two triangle congruences, side, 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 and side, angle, side. I usually list them as I go. So we know side, 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 and we know side, angle, side. Today we're going to introduce angle, side, angle, and angle, angle, side. Also, remember, I had you highlight the edge of one of your note pages that had a reference page for all of the triangle congruences. You will have 5 altogether. So the one we're discussing today is angle, side, angle, which means if angle A is congruent to angle D, side AB, line segment AB, is congruent to line segment DE, and angle B is congruent to angle E. Then we have, and again, I like to write the letters here because it helps me see it in the order that it occurs. So if we have right here an angle, this side and an angle, I can see that the side is right between the two angles. This one is angle, side, angle, congruence. So we're going to use that for a couple of these proofs right here. Every time I read a proof, I go through a proof, I make sure to mark on my diagram. So the first thing, SQ bisects, that's the wrong color, SQ bisects angle RQT and angle RST. So if it bisects that, well, first that's given information. I can say I know that because it's given to me. Well, RQS is congruent to TQS because that's SQ right there. And then RSQ, I'm going to put 2 marks, is going to be congruent to TSQ over here because it just told me it bisected here. So for both of those, it's definition of a bisector. Now, QS is equal to itself. QS right here is equal to QS. When can I say something equals itself? When it looks in a mirror. So this is my reflexive property. So now if I have this angle right here, this side right here, and this angle right here, do I have enough information to say these two triangles are congruent? And yes, I do. Angle, side, angle, congruence. So again, what I would do here if I were you, I would pause the video in a moment and I would answer everything you can. Can you fill in any of these? Now what I think helps is if I extend this line here, and I extend this line here, or I could redraw it if I wanted to. I could just redraw to, and I want to look at this line, KL right here. Now if I want to see it continuing on a little bit, I could extend it. Or I could just redraw it over here, so I can kind of see it separately. This is up to you. Some people can see it really fine just like it is. Some people need to draw extensions. Some people, I like to see exactly what I want to look at. So I don't want the rest of this stuff to cloud my vision, so I may want to redraw it or take like a little note card and cover it up, looking at exactly the pieces you want to look at for the problem. Now, because I've done that, I can see that I have a relationship between these angles here. Okay, so right now, I would go ahead and pause. Answer anything you can. This is enough information for you to be able to probably fill in quite a bit of this and see where you get. Okay, so the first thing here, the lines being parallel is given. As soon as I read that, I'm going to write that on here. JK is parallel here, so I'm going to put one little arrow here and here. JL is parallel to KM, so I'm going to put parallel lines here and here. I'm going to put 2 of them. So I know that the opposite sides are parallel. Parallel lines cut by a transversal. I want to prove this down here. Well, now let's look. Do we know that JKL is congruent to MLK? It's the angles I'm talking about right here. Why are they? What is their relationship? They are alternate sides inside. This is going to be alternate interior angles. Now what if I look at JLK, this angle here, and say it's the same as MKL, this angle here? Now this is similar. This is if I had extended these lines and cut the transversal this way, so I can see those other ones. So extending the lines helps me see that. Again, those are alternate interior angles. Well, KL is equal to LK because it is the same exact line. This is reflexive again. So do I have enough information? I have angle, this side, and angle. So how many were you able to get? All 5 of those, or maybe 3 out of the 5? Your goal should just be to get a few, maybe not all of them, but can you get a few of those connections together to make sense? Okay, I'm going to go to the next page. We are going to do, everything on this page pretty much. Again, pause if you need to, mark everything that you need. I am going to give you this information. I'm going to tell you that, and if you're okay with this, BAC is this angle here, DEC is this angle here. Instead of using all 3 letters to name it, because it's only one possible angle, I'm just going to say angle A is congruent to angle E, because that's the only possible angle it could be. I'm going to go ahead and put given. And I don't usually like to split up my given, so I'm going to go ahead and put this next one here. C is the midpoint of AE. Again, my reason is given. So these two, C is the midpoint of AE. It doesn't tell me it's the midpoint of BD. It says AE. So if I know C is the midpoint, what do I know? Well, if that's the middle, this right here and this right here have to be equal. So I'm going to go ahead and write that. I'm going to say AC, line segment AC, is congruent to line segment EC because that's my definition of a midpoint. Now I want to prove the triangle's congruent. So I know my last statement is going to be triangle ABC is congruent to triangle EDC. For some reason, got 4 of them right now. Why is it congruent? I have an angle, I have a side. My 4 triangle congruences are side, 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 angle, side, angle, and angle, angle, side. I have one side and one angle. There's not really another side I could prove, so I'm probably not using the first 2. And I haven't used angle, angle, side yet, so it's probably going to be this one. I need an angle, side, and another angle. What other angle can I prove? This angle C. Now, like I called these ones A and E, that was really great because it was only one, but if I say C, you don't know what I'm talking about. So with C, I have to be specific and I have to use 3 points to name it. So since I'm going to use 3 points to name that angle, I'm going to go ahead and say angle ACB is congruent to angle ECD. The reason they're congruent is Remember they make these B's right here. These are vertical angles. Okay, they are congruent because they have an angle, an included side, and an angle, so ASA congruence. Okay, so the fourth one we're going to talk about is angle, angle, side. Angle, angle, side means I need angle A to be congruent to angle D. I need angle B to be congruent to angle E. And now the non-included side. We go back here, two angles and an included side. If you want to highlight that from the last page, this time it is a non-included side. So this side would be line segment BC, congruent to line segment EF, and this time it is angle, angle. Notice that the side is not between the two angles. Angle, angle, side, congruence. So here I'm going to take my given, line segment YZ bisects. As soon as I read that, I am going to assume that probably my next reason, before I even write anything else, is probably going to be definition of a bisector. So anyway, back up to this. This bisects this angle WYX. This is given. Now I have a second given. I'm going to come back to that. Because I said, well, that says bisect. I'm probably going to use the bisector. YZ bisects WYX. That means it cuts this angle in half. So I'm going to have to name angle. And I can't say angle Y this time because it could be different angles. It could be WYZ. It could be XYZ. Or it could be the angle XYW, the whole thing. You don't really know if you just named it by Y. So because you don't want to be specific, you have to name 3 letters. So I know because it bisects that angle, cut those in half, that's my definition of a bisector. I also have another given, so I split the given here. I'm going to say angle WYZ, WYZ is congruent to angle YXZ. Oh, YWZ. I read that wrong. I'm like, mess that up. I was so confused. YWZ, this one right here, is the same as YXZ, this one right here. There we go. And that was given. So I have 2 angles. Do I have a side? The one side I know is going to be the same is this YZ because it is part of both triangles. So I could go ahead and say YZ is congruent to line segment YZ because that's my reflexive property. So now, my last statement always goes at the end here. We are going to put triangle WYZ congruent to triangle XYZ. Angle, angle, side. Remember, you want to go the closest route you can. So AA side, you don't want to go this way because you would skip a side and an angle. So you want to skip the fewest amount of things, and here I would just have to skip one side. So angle, angle, side. I could say side, angle, angle, but we don't usually say it that way. But it's the same thing. We start angle, angle, side. Okay, I'm going to pause and go to the next page. We're just going to do number 7 on this page, and I started doing the given already. So these 2 are parallel, And then the second part says H is the midpoint of LM. So if that's the midpoint, I know those have to be equal. So I'm going to go ahead and write those. And every time I have that, I know that the next reason is probably going to be my definition of that vocabulary up above. Definition of a midpoint. So I'm going to say line segment LH is congruent to line segment MH. Mark them. Do I have enough to say that the triangles are congruent? Can't really figure out another side. Can I figure out an angle? Okay, so one that's really nice is hopefully we all see this angle right here. Those two are those ones that those B's are kissing. They're vertical angles. So I have to name this angle GHL is congruent to angle JHM. Those are vertical angles. Now, is there another angle I can prove? Now, I could do this. I probably want to use my angle side. And I could do this either way. But remember, you have two parallel lines here. If I want to extend them, I can. Cut by this transversal. So I have this angle here and this angle here. Angle G is congruent to angle J because they are alternate interior angles. Now I have angle, side. So I can say triangle LGH congruent to triangle MJH by angle, side congruence. There we go. Yeah. Again, if you have any questions, put sticky notes to the side, come and ask me in class. Some of these get a little bit tricky. Okay, we're going to go to one more page, and we're going to introduce the fifth triangle congruence. Now, the fifth triangle congruence here says if I have a hypotenuse, so my hypotenuse tells me that I'm part of a right triangle. So my hypotenuse is BC, is congruent to EF, and a leg. So here, it doesn't matter if it's A, B, or AC. It could have been either one. They picked this one up here. So whichever leg they choose, in this case it is AB, congruent to DE. So first, I know I have a right triangle because it's a hypotenuse. So I have two sides. This is technically side-side angle. I feel like, did I talk about it earlier, that this side-side angle, that's a bad word if you read it the other direction. The bad word does not work unless it is a right triangle. So this is a special case of SSA. So our hypotenuse leg is our special case, and we know that if this is true, I can then say triangle ABC is congruent to triangle DEF. So I'm going to do one of these proofs. Right here, triangles are right triangles, that is given. I know that ML is equal to MN, that is also given. ML right here is congruent to MN. That's my hypotenuse. So do I have, oh, it's telling me a leg also. It's telling me that MP is congruent to itself. Do I already know that? Why do I know something has to equal itself? Because it's looking in the mirror, and that's my reflexive property. So now I have a side, and an angle. Can I say the triangles are congruent? Now technically, not if it just said side, angle. But because it is a right triangle, I can call it HL congruence. Remember that whenever you have pieces on a proof, you want to come up here and make sure you label your diagram, because it makes it just that much easier for you to see and follow through and use some shorter answers for a lot of the pieces. Okay, so good luck with those. Have a fabulous day. Come see me in class if you have any questions. See you guys next time.